So hello, I'm Jan Svoboda, I'm from Olomouc, and I prepared a video about Goguen categories. That's a glue between category theory and fuzzy logic. So, in a review of Goggen's work on fuzzy sets, Professor Bělohlavek wrote that in the early stages of the development of fuzzy systems, Goguen made profound contributions with lasting influence. Goguen PhD dissertation Categories of Fuzzy Sets was the first work to apply category theory to fuzzy logic and led to Goguen categories being named after him. Goguen category, a fuzzy kind of category in which membership is determined not in binary, true or false, fashion, but by a more general interval. The use of set membership as key component of category theory can be generalized to fuzzy sets. This approach, which began in 1968, shortly after the introduction of fuzzy set theory, led to development of Goguen categories in the 21st century. In these categories, rather than using two-valued set membership, more general intervals are used and may be lattices, as in L fuzzy sets. What is fuzzy set? Fuzzy set A is a set of ordered pairs of the element and in its membership in the set A. So this is membership, and this is the first element and its ordered pair. So you can read more on Wikipedia. I wanted to mention these kind of categories because of connection. I wanted to mention connection between category theory and computer science. Because of that, I choose these Goguen categories, and because of that, I prepared some notes from Categorical Manifesto, which is Categorical Manifesto is an article written by Goguen encouraging the use of category theory in computer science. This is really crucial thing, so I prepared some notes from that manifesto. In computing science, abstract viewpoints are often better because of the need to achieve independence from the often overwhelming, complex details of how things are represented or implemented. My quote, another abstract viewpoint in computer science, unified model language. But here is that node is you should understood that node like here category theory for programmers from Bartosz Milewski, applying categorical structures from category theory to computer programming. So that's the node from Categorical Manifesto. So another node, indeed many category theorists feel that the morphisms are more important than the objects, since they reveal what the structure really is. Okay, useful way to get an overview of a problem, theorem or proof is to draw one or more diagrams that show the main objects and morphisms involved. Okay, another quote from this article. Of course, the small categories also form a category with functors as morphisms. It's denoted cat, so that you can find this in that Categorical Manifesto or in lectures from Bartosz Milewski. It's a kind of category cat. Another note from Categorical Manifesto. This history also explains why homology theory so often appears in categorical texts, and hence why so many of them are ill-suited for computing scientists. That's pretty crucial note, I think, that homology theory in categorical texts, that it's not useful for people in computer science. So these are notes from Categorical Manifesto. And here quickly something about fuzzy logic. So fuzzy control system, although alternative approaches such as genetic algorithms and neural networks can perform just as well as fuzzy logic in many cases, fuzzy logic has the advantage that the solution to the problem can be cast in terms that human operators can understand, so that their experience can be used in the design of controller. So extreme application, there is article, short-range missile autopilot design using fuzzy control technique. Another applications of fuzzy control techniques can be in medicine. So here is 4G, because fuzzy logic is part of artificial intelligence, so it's important to know 4G neural networks. So card poll can be controlled by reinforcement learning, by neural network. This Goguen tutorial. So that's one application of how card poll can be controlled, but there is another application, fuzzy controller, fuzzy logic examples, fuzzy logic part 3, that's the video on YouTube. So in that video, a card poll is controlled by fuzzy logic and not by deep neural network like here. So that's about control. Another thing, fuzziness in neural networks. There is book, Fuzzy Partial Differential Equations, and there is a chapter, Fuzzy Neural Networks based on Fuzzy Logic Algebras for Relations, and here is described fuzziness within neural networks, so you can read it, that there is fuzziness, you can have fuzzy neural network like this fuzzy neural network. So that's interesting, not just understand. For G, you can also program within PyTorch fuzzy neural networks. That's interesting, but I will not be speaking about that here. I just wanted to mention these Goguen categories, which are the beginning of fuzzy logic, and there is book on Goguen categories written by this man. So it's probably professor of computer science, I don't know, I think he is. So chapter 5 is dedicated to Goguen categories and several weaker structures. For what's important, in the last chapter we will give an applications of Goguen categories in computer science. So for G, fuzzy controllers in Goguen categories. I'm more interested in category theory than fuzzy logic, but it was pretty interesting for me to realize that that category theory helped so much to computer science. I knew about applications like category theory for programmers, or these lectures from David Spivak, or this article, backpropagation as functor, or categorical databases that I knew for years, but I never realized that category theory connected computer science and category theory, that you can connect it so deeply by these Goguen categories. That this guy was this Goguen, he was really genius, really connecting category theory and computer science. So that's everything. Thank you for attention, and that's the end of this video. Bye.